point-slope form of a line, the formula we'll be using is y minus y sub 1 equals m times x minus x sub 1. That is the equation of a line passing through the point x1, y1 with slope of m. We're asked to graph and write the equation of the line in point-slope form that passes through a given point with a given slope. The point is 3, 5, and the slope is 4. Now, if you have access to a coordinate plane or graph paper, it's a good idea to start with that coordinate plane. And let's plot the point 3, 5. The slope is 4. Instead of going up 4 to the right one, let's go down 4 to the left one and continue. And now let's connect those points with a straight line. So there is the line. We're asked to write the equation of that line in point-slope form. Well, I could use slope-intercept form because I know the slope and I can see the y-intercept, but I'm going to start with the form of the line that was asked. And I'm going to substitute in place of x1, y1, the numbers 3 and 5, and the m in the formula will be 4. So I have solved the problem that was asked. That is the equation of the line in point-slope form. To see that I did not make a mistake, I could rewrite this equation in slope-intercept form by distributing the 4 inside the parentheses and now adding 5 to both sides, and then just checking that my y-intercept of -7 looks correct, and that is correct. Next example, I'm going to be given a point and a slope again, but this time the slope is 0, and we'll use y minus y1 equals m times x minus x1. And this time we can substitute directly into the formula. So y minus 3 equals 0 times x minus 2. That is the equation in point-slope form, passing through the point 2, 3 with a slope of 0. Now let's multiply on the right-hand side. 0 times anything is 0. Let's add 3 to both sides. The equation of this line is y equals 3. That's one of the special case lines. Let's see why. Let's first plot the point 2, 3. And remember, a slope of 0 is a horizontal line. Any point that lies on that line has a y-coordinate of 3. That's why the equation is y equals 3. Here we're given 2 points, -1, 3, and 4, 5. Let's plot those points. And let's draw the line that passes through the points. You'll notice the y-intercept is not a lattice point, so it's difficult to use the slope-intercept form. Let's use our point-slope form instead. We need a slope, right? So here's your rise and here's your run. The slope is 2 over 5, positive. All right, here's the formula that we need. We'll substitute 3 in place of y1, -1 in place of x1, and the slope is 2/5. Let's simplify inside the parentheses so that it's x plus 1. And there is our equation in point-slope form. Notice how we tackled this problem was we started with the coordinate plane to find our slope. That is not the only way to solve this problem. Let's show you another strategy. Okay, same problem, but this time without using the coordinate plane. Here's the formula for slope. Now let's plug in the numbers 5 and 3 respectively for y2 and y1, 4 and -1 respectively for x2 and x1. Let's simplify the denominator and the numerator. We still get a slope of 2/5. We just got that slope algebraically. We're going to go through the same steps to get the equation of the line. and we will get the same equation. So some people have a preference to use the coordinate plane. Other people have a preference to use the algebra. Be thinking about your own preference for these problems. Here I've given you an equation, and I'm asking you to graph it. Now, there's two approaches. We could simplify it and write it in slope-intercept form and graph it that way, or we could think about our point-slope form of the line. We could rewrite our equation as y minus a negative 3 equals m, in this case negative 2, times x minus 2. So a solution, or a point that this line passes through, is 2 comma negative 3. The slope will be negative 2, and we can graph this now. Let's graph that point, or that solution, to negative 3. And because the slope is negative, we'll go down 2 and to the right 1, or up 2 and to the left 1, up 2 and to the left 1. Let's draw the line that passes through those points. And there is the line that was given to us in point-slope form. So notice I gave you the equation and I asked you to graph the line. Finally, if I give you the graph, you should be able to write the equation. So here's the graph. Let's identify that bottom point as 2, negative 2. So that will be our x1 comma y1 in our formula. The slope is rise over run. This has a positive 3 for a slope. The formula we'll be using is there. We're going to substitute in our y sub 1 and our x sub 1. And we're just going to rewrite it so it's y plus 2 equals 3 times x minus 2. So there is the answer to this problem. That's the equation in point-slope form. Now, just to make sure we didn't make a mistake, let's distribute the 3 and see what we have for slope-intercept form. Subtract 2 from both sides. And does it look to you on the graph like negative 8 is the y-intercept and the slope is 3? Right, now somebody might be thinking, how come you picked the bottom point? Could I have chosen the top point to use? We're going to solve this same problem, but using the top point, and hopefully we'll get the same equation. All right, so here's our top point, which is 3 comma 1. Slope is still 3. Same formula, but this time we're plugging in 1 for y1 and 3 for x1. And we will distribute the 3 inside the parentheses and add 1 to both sides. Notice it is the same equation, no matter which point you chose. So that was a little review of point-slope form of a line.